Good morning. I'd like to talk with you in a brief presentation about a mission, an instrument that I've been working with through our ILOA, our International Lunar Observatory Association, for a couple of years. A demonstration of an instrument that's going to be tested later today, an instrument that's on the way to being flight readied, and will be tested very near here in conjunction with one of our joint venture partners, Moon Express, and in particular Bob Richards, the principal of Moon Express, and his other affiliated organization, INTEC, has done the development of the ILOX precursor. You'll see on that introductory slide the various elements of the key elements of ILOA, and the lower center is the ILOX instrument mounted at the center front part of the Moon Express bus. Top right and lower left are artist versions of the original ILO-1 mission. I'll have a couple of words about that later. Bottom right is a artist concept of a landing chair for the human service mission to the ILO, and top right is the Kaguya image of the area that we intend to operate our missions on the moon, the South Pole Malapert Mountain area. A few words introductorily about the ILOA, a few salient characteristics. It's an astronomy mission, a galaxy-focused mission, interstellar. It's multi-world. We're located, the ILOA headquarters is located on the big island of Hawaii in the north-central town of Kemuela. So it's an Earth-Moon interglobal mission. As I mentioned, it's Hawaiian and it's also multifunctional. In this case, we'll talk about its two preeminent functions of observation and communication. The three missions, briefly, in the center there you see the precursor mission, and we'll be talking in more detail. It's the central focus of this talk about the precursor instrument to fly with one of the Google Lunar X Prize early contenders. I mentioned Moon Express. Top left is a artist's depiction of the results of a study, the latest study that we did on the original ILO-1 mission that's also to land at the South Pole on a spacecraft of about 50 kilograms, and then bottom right, the human service mission that we are conducting networking operations to identify individuals, organizations, and governments interested in a consortium to send a person or persons back to the moon for science and technological reasons. The ILO-1, as I mentioned, we've conducted two studies with MDA Canada on the mission itself. Previously, we conducted 6 studies on the mission and its related human service mission with SpaceDev under the leadership of the late Jim Benson. The objectives of the main mission, first light will be, we spent many years really trying to determine what were the best images to take and where to look first. We wanted something grand, as comprehensive and educational as possible, directional and inspirational. So we decided to take first light from the central part of our Milky Way galaxy. After the first light, the camera will be tilted down to pan across the lunar surface, imaging the local surroundings for site characterization, and then raised again to image the whole Earth disk of the Earth for climatological and whole Earth observations. Being an early arrival at the moon, at this new world, there are an infinite number of astronomical objectives to consider, exciting ones that have long been talked about, whether it's extrasolar planets, SETI, analyzing the interstellar dust, VLF observations, observations from the moon of the atmospheres of solar system planets, searching for the incoming dangerous rocks, the NEOs, space weather, and many, many other possibilities. We are landing, we're hoping to land at the South Pole area, the Malapert Mountain area, and we've collected imagery over the last couple of years, including most recently from LRO and from our international collaborators in China, in India, and Japan, Europe as well too, of the South Polar region, and have begun a GIS study to characterize the exact site where we want to land for safe and precise landing reasons, as well as for future development reasons. The precursor instrument you can see top right, it is equipped with a tunable filter, hyperspectral CCD, and to be mounted on the Moon Express bus for earliest possible arrival at the moon, perhaps before 2014. Intech was the affiliated corporation that Bob Richards of Canada ran for us, so this is a Canadian-developed instrument. There's the instrument on the left, Bob, who most of you know. And this instrument is concluding phase one of the prototype with the camera. It's just a single unit that we're focusing on. The demonstration will be, as I said, local. It will be a device that can be operated remotely. We have astronomy science teams cooperating around the world this afternoon in Canada, India, if it's not too early there, China, Europe, and in Hawaii. And we expect to include other regions and other nations as we move forward into phase two, about 5 months from today, on Mauna Kea, with a global demo of a complete system. I want to thank one of my ILOA fellow directors, Joseph Sula, for this composition. These next two slides, and I'm sorry that he's not here to better explain them. Some of the characteristics of the instrument: high resolution, I believe 12 megapixel sensor, 600 millimeter focal length, 4-degree field of view for the central part of the galaxy as well as the whole Earth disk, both occupying about 4 degrees of imagery. And a liquid crystal tunable filter in the optical path. I think it's 400 to 720 nanometers. As I mentioned, this instrument is being developed for flight operations, and as I also mentioned, the next stage after today, assuming we have success in operating pointing the camera from our international collaborators and taking an image and then posting it to a website, which will help us in our communications and broadcasting goals. ILOA is affiliated with our long-established space age publishing company based here in Silicon Valley. And by the way, as far as the Hawaiian connection, space age, and I've been operating in Hawaii since 1986, so we have some experience there. More detail that Joseph put together. The main mission of ILOA is to expand human understanding of the cosmos through observation from the moon, very straightforward. With this precursor test today, we'll be demonstrating astronomical observation possibilities by testing the telescope components, enabling use of the telescope with the astronomical community around the world. Communications, demonstrate communication to user ground stations from ILOX instruments on the moon, and applying these lessons to full broadcast capability that the original ILO-1 mission is developed for. That was the artist's slide you saw with the big, ideally 2-meter dish that we hope characterizes the ILO regular full mission. I mentioned that once we have these communications checked out, we intend to communicate not just astrophysical data obtained from the instruments on the moon, but to provide communication services through our space calendar publication weekly, and advertising possibilities, commercial possibilities as well. The human service mission, you can see the astronaut servicing the ILO-1 with that 2-meter dish I mentioned on the left there. There's an image of our friend and pioneering entrepreneur Jim Benson, who much tribute to him. We just saw yesterday with this new era that we've entered today. This is really a poignant time. A new era, post-shuttle, very post-Apollo. And I just saw the ratings from an Irish bookie as to which new space enterprise would be the first to deliver astronauts to the space station, and Sierra Nevada Corporation's Dream Chaser that Jim Benson brought back and put into commercial development is I think rated 7-4 odds to be the first to succeed sending astronauts to the space station. So here's to Jim, and here's to the idea of Galaxy Enterprise, which is a grand idea in a new era that I think we are now in. Galaxy Enterprise, something to think about. We have developed through our Galaxy First Light imaging program. We've developed a Galaxy Forum public education outreach program, first to advance Galaxy 21st century education in every class around the world, and second to identify support for that education. And you can see the widespread areas that we've successfully conducted Galaxy Forums, and will continue in this direction, including Antarctica. Why Galaxy? Well, why Galaxy education and consciousness is important for the 21st century, I won't go into right now. There's some very strong, compelling reasons. Education, long-range planning, Galaxy consciousness, galacticity, if you wish, so that in the 21st century, when we get back to the moon and look at the galaxy, it may be as significant as in the 20th century, looking back at Earth from the moon was at that time. Galacticity may be as important in the 21st century as relativity was in the 20th. We're multifunctional, including hopefully the toehold for human build-out on the south pole of the moon. We're interglobal. Those red dots represent the organizations and areas of support that we have. There's a list of them and their logos. Why Hawaii is important. Frank Schoeninger gave a very good explanation of why Hawaii is important for 21st century human expansion into the cosmos. Mid-Pacific location in Mauna Kea with the TMT Next Generation Telescope bottom right there. Assets were well equipped to go forward, and we'd be happy to answer any questions you may have about the ILOA or this ILOX demonstrator. Thank you.
One very, very quick question, I hope. Why don't you just shout it out? So.
Well, great talk, Steve. I was curious if you would say some words about your reference frame for doing exposures from the telescope. How do you do pointing within some reference frame and software for these different options?
Well, that's a good question, Rob, and thank you for your comment. One of the a couple of the Moon Express software engineers have developed a package that has been loaded into the demonstration today, and that package of software has been made available to the operators around the world. Anything that deals with computers, I'm very, very skeptical about, so we'll see by the end of the day, literally, what we have, and I'd be happy to fill you in on the results.
I think with that,